The topic of this video is solving rational expressions equations. Let's look at a problem. Solve the equation 4 over x minus 4 minus 4 over x minus 4x plus 2 equals negative 6 over x plus 2. Alright, so let's go through the 5 steps together. Step 1 is to determine what the answer cannot be. And the way we do that is we set each denominator equal to 0. So x minus 4 is not allowed to be 0. X minus 4x plus 2 is not allowed to be 0. X plus 2 is not allowed to be 0. Solving each one of these inequalities, we get x is not allowed to be 4, x is not allowed to be negative 2, and using the zero product property, we get x minus 4 is not allowed to be 0, x plus 2 is not allowed to be 0, and therefore x is not allowed to be 4, x is not allowed to be negative 2. Notice that these are duplicated values. We don't need to list them twice. So what we've learned from step 1 is that the final answer to this question cannot be 4. It can also not be negative 2. X cannot be 4 or negative 2. All right, that moves us on to step 2, 3, and 4. In steps 2, 3, and 4, we find out what the answer might be. Here's how we begin. The first thing we need to do is to make all of the denominators into the least common denominator. So I'm going to rewrite my equation. And now we are going to begin the process of making all of our fractions the same. For example, this denominator is x minus 4. This fraction's denominator not only has the x minus 4, but also has an x plus 2. Therefore, this first fraction needs an x plus 2, top and bottom. Now, these two fractions have the same denominator, but the third does not. It needs an x minus 4. Okay, now all of our denominators are the same, and we have found the least common denominator. The least common denominator for this problem is x minus 4 times an x plus 2. So I'm going to rewrite my equation to look like this. 4 times the x plus 2 over the least common denominator minus 4 over the least common denominator equals negative 6 times the x minus 4 over the least common denominator. And we recognize that the least common denominator is this pair of binomials. All right, the next step in solving this problem is to clear the fractions by multiplying both sides by the least common denominator. When I say both sides, I really mean both sides. The entire left side and the entire right side are going to get multiplied by the least common denominator, LCD. LCD. On the left, it will be distributed here and here. On the right, it will simply multiply. Now, if we are thoughtful and careful, we will understand that when the LCD is distributed to this first fraction, the LCD up top will cancel the LCD down below, leaving us just the numerator. Similarly, because of the distributive property, this LCD is also going to reach this second fraction where the same thing will happen. This LCD will cancel the 1 in the denominator, leaving me just the numerator, subtract 4. On the right side, this LCD and this LCD cancel, leaving me just the numerator, shown here. Now we just have to solve this equation. So let's go ahead and distribute. I'm going to do this work while I'm moving up the column here. I'm trying to be a good manager of the space that I have available to me. Distributing, this is going to be 4x plus 8 minus 4 equals negative 6x and a negative times a negative is a positive, and 6 times 4 is 24. Combining like terms, this gives me 4x plus 4 equals negative 6x plus 24. Now I need to collect all terms that contain x on one side and all terms that do not contain x on the other. So I'm going to move some terms around. For example, this term will move from the right side to the left. This term will move from the left side to the right. And when a term changes sides, it changes signs. So I get 4x plus 6x equals negative 4 plus 24. 10x equals 20. And by dividing both sides by 10, we get x might be 2. I'd like to remind us all that in steps 2, 3, and 4, we're finding what the answer might be. We found that the answer might be 2. All right, we're now ready to move on to step 5. Step 5 is where we find out what the answer is. The first thing we're going to do is take each possible answer and compare it to what we discovered in step 1 as invalid answers. So, is 2 acceptable based on what we learned in step 1 of this problem? The answer is yes. X cannot be 4, x cannot be negative 2, but 2 is okay, as long as it really is a solution to our equation. How will we know if it's a solution? We will plug into the original equation and simplify. So we're now going to do step 5. We're going to take our equation, and everywhere we see an x, we're going to put a positive 2. So, a positive 2 here, 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 here. Now we simplify to see if the left side and right side are equal. 2 minus 4 is negative 2, so I have 4 divided by negative 2. Similarly, this 2 minus 4 is also a negative 2, and this 2 plus 2 is 4, equals negative 6 over 4. All right, now let's begin to simplify. Notice that this 4 and this 4 can be canceled. Each one of those is going to turn into a 1. So 4 divided by negative 2 is negative 2 minus, then I have a negative 1/2 equals negative, reduce this fraction, 3/2. Now subtracting a negative is the same as adding, so this will be negative 2 plus 1/2 equals negative 3/2. Negative 2 is the same as negative 2 over 1. And to get a common denominator so that I can add both of these fractions, I'm going to multiply the bottom and the top by 2. So that gives me negative 4/2 plus 1/2 equals negative 3/2. And that is a true statement, because when fractions are added, you keep the common denominator, but you add the numerators. Negative 4 plus 1 is negative 3. This is a true statement, and that validates our answer. So our final answer is x equals 2. And that is the end of this problem.